Sorry for the technical difficulties, but we should have it figured out now. So Terry Barker has been an amateur astronomer for most of his life. He received his first telescope at age 12 and used it almost every clear night for several years. Since then, he's earned degrees in math and physics, taught secondary school math, physics, and chemistry, and has served as a judge in the Richmond area STEM for over 10 years. He's been a member of the Richmond Astronomical Society since 1988. I can read, I promise. Serving as president in the past and currently as club outreach coordinator. He hosts club skywatches for schools, scouts, libraries, and other interest groups.
And you should be good to go.
Thank you. All right, on this document that I'm going to pass around also, this is comparing.
Microphone, please. Use the microphone.
I will use it in a second.
We can't hear you.
I want to talk down here.
We can't hear you.
Can you hear me now?
They can't hear you in the back.
This is also comparing the size of the sun to other stars. As you can see, they're much larger too than the sun. So our sun is not the largest object. It's not the largest star. All right, now.
That's a good question. I don't know. When they start talking about
Okay, is that better? Can you hear me now? Yes. Okay, I passed around one poster that compares the Earth to the sun, and then I sent around another poster which compares the sun to some other stars. And as you can see, our sun is not very big at all, even though it seems very big for us on Earth because we're so small. But anyway, as far as the presentation goes, we're going to talk about a word that connects two entirely different subjects. Come on. Oops. All right. This is why I asked if anybody here had seen The Terminator. I think a few hands came up, right? The Terminator. It's a movie, science fiction movie. Okay, how many of you have seen it? Okay, well, the word that I'm going to use to connect the two disciplines that I'm talking about is the word singularity. A black hole, you may or may not have heard about. It's not something you're going to see in your lifetime. It's just something that you're going to hear about. It's a one-dimensional object that is so small that it's undefined. The physics is completely undefined. The word singularity can apply to two different things. One is towards a black hole, and one is to artificial intelligence. Have you heard about artificial intelligence? ChatGPT? Maybe not so much. ChatGPT is the latest reincarnation of artificial intelligence. And a lot of people are worried that artificial intelligence is going to become so intelligent that it's going to become smarter than humans. And that's what two of these ideas are about. Artificial intelligence, the word singularity applied to artificial intelligence, is the point at which artificial intelligence is so smart that it's smarter than human beings. How many of you play chess? Oh, a couple, okay. Well, you probably realize that we have artificial intelligence machines that can beat the smartest chess player on the earth It's happened multiple times.
Where can that be if it's programmed by people?
Machines can learn. That's what ChatGPT is all about. ChatGPT is the latest version of artificial intelligence. And the reason that people are, I kind of use the term afraid of it, is because it seems so smart. It actually can come up with ideas that you didn't ask it about. It came up on its own. Now, you're correct in that machines are just programmed by humans, but the reason that artificial intelligence can be so smart is because, as with chess, the more games that the machine plays with chess, the more it learns. Now, it can't come up with ideas like a human being can, but it can do a lot of things that are seemingly inhuman, like beating you at chess, or building a robot that's so smart that eventually it decides that it's smarter than human beings, and they don't need human beings anymore. That's what the Terminator movie is all about. It's about a time in the future where machines are smarter than humans. They've decided they don't need humans, so they start to exterminate humans. And that's the idea behind this robot that's called a Terminator. You know who Arnold Schwarzenegger is, right? That's one of his biggest movies. If you haven't seen it, I recommend it. Not only is it kind of scary and scary to think about, but it's actually a pretty good movie, even though Arnold's not all that great in his acting. But the plot itself is really good. So, singularity, then, when it is applied to artificial intelligence, is the point at which machines are smarter than humans. We may be approaching that point, but we don't think we're there yet. But it could be sometime in the future. A black hole also uses a word that's called a singularity. And that's the point at which the center of a black hole contains all of its mass. For instance, if you think about Earth, we all know that the Earth is composed of mass that we perceive as dirt and trees and buildings and rocks, et cetera. Okay? With a black hole, there is no body. It's just a point. But all the mass in the black hole is concentrated in that area. In fact, the concept, well, we'll talk about this in a little bit, but the concept is so scary that even scientists had a hard time with it. So, we're going to talk about a word, singularity, that applies to two entirely different things: black hole and artificial intelligence. They're not actually connected, but I like the idea of using a single word to connect two different disciplines. And we have a lot of fun talking about the Terminator. In fact, over here, we got a black hole. And over here, we got the Terminator. And what's the connection? There really is no connection, but we can use a word that gives us a connection. Do any of you remember seeing this image on the left in the paper? It's the first image that we ever have seen of a black hole. And it's actually not something that you can see with your eyes. It was constructed by a bunch of different telescopes. In other words, you can't go to a telescope and look up at the sky and see this. But I'm going to explain how we got that image here in a minute. Do y'all have movie nights here? Okay. Recommend the Terminator. In fact, I think there's 4 or 5 of them. But the original one's much better. Artificial intelligence. The singularity is the point in time when machine intelligence will exceed human intelligence. It's an offshoot of Moore's law about transistors. And that law says that the area that a transistor contains will decrease by a factor of 2 every year. And so far that's come true. We're all familiar with TVs, right? You probably have a TV in your room. Remember how big they used to be? Well, this is Moore's law in action. To encapsulate, Moore's law just says that you can fit more and more electronics into a small area over time. And it approximately doubles the capability every couple of years. And so far, that's been true. But the human brain will hit a wall but not necessarily artificial intelligence. Advances in AI will allow machines to reprogram themselves. Hello, Terminator. That's how chess machines became so smart. The original computer that learned chess just learned the rules of chess, okay? No big deal. You know, a third grader can learn the rules of chess. But a third grader doesn't have the capability to play a grandmaster, right? But if that third grader plays enough games, they're going to get smarter and smarter and smarter, right? That's what happens with artificial intelligence. Artificial intelligence has the capability to learn and reprogram itself to get smarter and smarter and smarter. This newspaper headline is a joke. Remember when England was going through Brexit, leaving the European Union? Well, they were making a joke here because just about the time they were talking about Brexit, they discovered or created this first image of a black hole. So this is kind of a joke about politics involving a black hole, what Brexit looks like from space. It's a joke, it's not real, but it's funny. Now here's how we started learning about black holes. Sirius is one of the brightest stars in the sky, and it's bigger than our sun. Well, as scientists studied Sirius, they began to see that it wobbled. Not a whole lot. Took a telescope to figure it out, but it wobbled. And they were trying to figure out why does it wobble? Well, they finally discovered that there was a companion to the star that rotated around Sirius just like the moon rotates around the Earth. They couldn't see it for a long time because, as you can see from this diagram, it's really small compared to Sirius and not very bright at all. So for a long time, they could not figure out what was causing that star to wobble. But as telescopes got better and better, and they figured out what they were really trying to look for, they finally discovered this little star. Well, this star was so small, and you can see from the diagram how small it is. How could that little tiny thing have such an effect on Sirius and make the entire star wobble? Well, that led to a theory that this is actually not a normal star. It's called a neutron star. If you take an atom, if you remember back from your high school science classes, you all remember probably that an atom is made up of a nucleus made up of neutrons and protons and electrons that rotate around it. Well, the electrons are not right on top of the nucleus, they're quite a ways away. In fact, if you can visualize an electron the size of a football stadium, the nucleus would be the size of a softball in the middle of the stadium. And the electrons would be at the distance of the upper level of the stadium seats. That's how much empty space there is in an atom. Well, if you collapse all that, where there's no electrons anymore, and all you have left is the nucleus, well, the atom is quite a bit smaller, isn't it? Well, that's what a neutron star is. It's a star that is so big that gravity has overcome the separation between electrons and neutrons, and the entire mass of the star has collapsed to a tiny, tiny amount. In fact, it's so collapsed that if you took a teaspoon of a neutron star, it would weigh several tons. So that was how we figured out what a neutron star was, and then things got more curious and more curious. An Indian, whose name I cannot pronounce, theorized what would happen with even larger stars. Remember, a neutron star is caused by a star so big that its gravity overcomes the separation between electrons and the nucleus, and it collapses. Well, what would happen if you had a star that was even bigger than what creates a neutron star? He applied quantum theory and came to the conclusion that stars should collapse even further into a single point. Now, when I say a single point, I mean not something that's that big, not something that's that big. It's something so small you can't see it. But it contains the entire mass of that star. It's really hard to think about. It's almost like an artificial intelligence. In fact, the most famous astrophysicist of the time, Arthur Eddington, ridiculed it. He said, that's ridiculous. And that's probably what you all are thinking right now. This is pretty stupid. And a lot of scientists could not accept the fact. But we now know pretty much. I mean, you can't really see a black hole, but in analyzing the effects of gravity, it's the only thing it could be. Einstein, one of the smartest men of all time, could not accept this and wrote a paper that refuted the existence of a singularity. There's a curious parallel between the histories of black holes and continental drift, which we all know is true, right? You probably remember that from high school. Evidence for both was already non-ignorable by 1916, ignorable. But both ideas were stopped in their tracks for half a century by resistance bordering on the irrational. In other words, it seems pretty much acceptable nowadays that black holes exist, but back in 1916, most scientists could not believe it. First image, called Event Horizon. It's in this galaxy that's pictured on the right, and then the image on the left is a blow-up of what's pictured on the right. It's hundreds of millions of light years away. It's so small. That's one of the reasons why we couldn't get this image for a long time. It's so small that it took multiple telescopes to create the image. It took a telescope as large as the Earth. What you can do with multiple telescopes is you can combine the image, and the further apart the telescopes are from each other, the smaller the image is that they can see. So it took a telescope the size of the surface of the Earth to actually create this image. It's not a visual image. It's not something you can see with your eyes. These telescopes are not optical telescopes. Optical telescopes are telescopes where you can look through an eyepiece and actually see something. A radio telescope collects radio waves instead of light waves, and we're not going to get into the electronics of this. But anyway, it took 7 telescopes scattered over the entire surface of the Earth to create this image. It was created by a computer. It's not something you can look at an eyepiece and see. But that's how we created the first image. Do any of you ever listen to WRVA? Well, when this image was first created, a guy was joking on WRVA, and he said, "You all really don't believe that image, do you? That's just a donut with some orange icing on it." That's kind of what it looks like, doesn't it? Now, if the black hole is black, and it's in space, which is black, how can you see a black hole? Especially it's so small, it has no body. It has no surface. How can you see it? Well, you can't. But because the gravity is so strong, it captures things in space, rocks and asteroids, that are sucked into orbit around the black hole. And because this matter that's circling the black hole rubs each other as they go around the black hole, creates friction. And friction creates heat. And heat creates light. So what you're seeing, the yellow and orange material around the black hole is stuff that's in orbit around the black hole. And then in the middle, of course, is the black hole, which you can't see. But as you can see, we can see things around the black hole. That's how we know that that's probably what it is. Now, nobody's actually seen the black hole, so we don't know for a fact that that's what it is. But all of science points to it. Now, here's kind of a breakdown of the material that's creating a whirlpool around the black hole. Now, in the middle, you'll see a black disk, which represents the black hole. Now, like I said, you can't really see the black hole, and it doesn't have a surface. Even though that black disk looks like it represents a surface, that just represents the point at which light cannot escape. The gravity of a black hole is so strong that even light cannot get out. That's why it's a black hole. So the disk just represents the point at which light cannot get out. If you get far enough away, light can escape. But within that black disk, light cannot get out. And one of the other things that's created by a black hole is called a relativistic jet, that blue thing that's shooting out the top. When the material gets sucked into the black hole, the energy is so great that some of the material actually gets shot out of the top. Or if you think about that representing the Earth, the North Pole. The jet comes up out of what would be the North Pole. And here it is with an artist diagram that kind of shows it a little better, a little easier to see. The disk that goes around the black hole is called the accretion disk. And then you can see that blue jet shooting out. And when the blue jet, the velocity is so great that sometimes it catches up with material that has slowed down, and it creates what's called a shock wave, which represents an even higher temperature than the temperature of the jet itself. So it shows up as a kind of a little object all by itself in space. And here's an actual image of the black hole, the outside of the black hole. You can see the black hole up to the left represented by that star. And then you can see the jet shooting out. And then the bright stuff at the lower right is the shock wave, where the fast material is catching up with the slower material. And the galaxy where this was discovered is called M87, which doesn't really tell you a whole lot, does it? The M represents a catalog that was made by a Frenchman named Messier. So he has a lot of objects that are numbered beginning with M all the way up through, I think, 101. We've discovered many more objects since then, but he created the first catalog. Some facts about black holes. A black hole will eventually evaporate. Now, this is a theory, because this takes a long, long time, due to what's called Hawking radiation. I'm not going to go into the physics of that, because that gets a little scary, too. In fact, it's actually called, Einstein actually called it spooky action at a distance, but I'm not going to go into that. It was first discovered, or black holes were first discovered by analyzing a bright binary star that emitted powerful X-rays. That's the Sirius and its companion that we talked about at the beginning. And black holes are created by collapsing stars 20 times larger than our sun. Now, as you can see by the diagrams I passed around, there are a lot of stars that are much, much larger than our sun. Black holes are not just things here and there. We now theorize that black holes are at the center of all galaxies, including our own. Now, we can't image our black hole because there's a lot of dust between the black hole and us, so we can't see it. We're just lucky that we can see it in other galaxies where maybe there's not so much dust that's hiding the black hole. I just read an article today that we're going to send a mission to Jupiter and Saturn. It's actually a European mission called JUICE, J-U-I-C-E, which is an acronym for something, but I can't remember what all it was. But anyway, as you can imagine, as you get further away from the Earth in space, things get pretty cold, don't they? Yeah. Have you read stories about how cold it gets on Mars? And Jupiter's even further away, and Saturn's even further away. Well, we think there might be liquid water on Saturn, or on the moons of Saturn. Now, how can that be? How can you have liquid water? Something that's, 20 times further away from us than the Earth. Well, it turns out that the moons of Saturn do not have completely circular orbits. Sometimes they're close to Saturn, sometimes further away. So it creates a tidal wave within the moon itself, which creates friction. The gravity of Saturn actually flexes the body of the moon. And when it flexes, that creates heat. And there's enough heat, they think, that is generated where there actually could be liquid Mars on some of the moons of Saturn. And we're getting ready to launch, or Europe's getting ready to launch a mission to actually investigate that. We actually have seen jets of water being shot into space from kind of like volcanoes on the surface of some of the moons of Saturn. In fact, one of the moons of Jupiter, Europa, they think has more water than all of the Earth's oceans. And Europa is much smaller than our moon. So, water's good. Wherever there's water, there's a possibility of what? Life. Have any of you ever seen a movie called, I think it's called, Europa Mission? Nobody? Okay, there's another one you can put on your list. That's about an actual mission to Europa. It was made several years ago, so it was really forward thinking. I also have what's called an infographic down here on the table, which gives you an image of where the water is on Europa. And then there's the Titan mission. Did you realize that we actually have a spacecraft right now sitting on the surface of one of Saturn's moons? It's the largest moon of Saturn. It's called Titan. And it released a probe called the Huygens probe in 2005 that actually landed on Titan. And if you Google it, if you Google the mission and the Huygens probe, it's the Cassini mission. If you Google Cassini mission, you'll also be able to learn about the Huygens probe, which is a spacecraft that actually dropped down on the Titan. Took a video, and you can actually see it. You can see the video, and you can see mountains and valleys, just like, similar to Earth, except it's not Earth. And the reason Titan is of interest because Titan also has a lot of liquid. It's not water, it's methane, which we don't think can support life, and who knows. There could be a possibility of other life forms besides ours, right? As if you've ever seen any horror movie, you can probably envision that. Okay, that's it. Questions about anything? Thoroughly confusing?
Yeah.
Yes.
I liked your presentation. It's really fascinating. I was wondering if your club ever has meetings where the members have their telescopes
Oh, yeah.
in kind of a dark area and look.
Yes, our club has a skywatch.
Repeat the question, please.
Oh, the question is, does our organization ever have get-togethers where people can look through telescopes? And we do. I belong to the Richmond Astronomical Society. We meet monthly at the Science Museum, and we also hold skywatches on the front lawn of the Science Museum once a month. The next one coming up is May 5th. And all you have to do is arrange transportation there. It's free. And just show up around dark, and you'll see telescopes set up on the front lawn. And you're free to go up and just tell somebody you want to look through their telescope, and they'll be happy to help you out. Right now, you can see Mars and Venus, which are planets, of course. And if you're in a spot where you can actually see the horizon really well, which is tough in Virginia because there's so many hills and trees, you can actually see Mercury right after sunset. But we also look at the moon and double stars. Remember I talked about Sirius and its companion? Most stars are double stars. Most stars have companions. And in fact, there's several that you can see easily through a small telescope that are as large as 6 stars rotating around each other. They rotate around a common center of gravity. 6 stars. One of them is in the constellation, the Big Dipper. There's a famous double star in the handle of the Big Dipper called, the 2 stars are called Mizar and Alcor, one of the first double stars that was ever noticed because you can see it with your eyes, even in Richmond. You can, if you look at the middle star of the handle of the Big Dipper, you can see 2 stars there. And easily with binoculars or a small telescope. So if you're interested in coming to a meeting, we also have meetings at the Science Museum where we just get together, like a bunch of geeks, and we just talk about stuff. One of our recent meetings was about the possibility of life in the universe, life besides us. I mean, we have life, right? Other life. Have you ever heard of? Well, you've all heard, I'm sure, stories about searching for life. Just like I was talking about the JUICE mission. We're looking for the possibility of life on the moons of Saturn. Okay. Well, I just read a book recently that has a pretty interesting aspect of that. we assume that if we find another life form, that they'd be friendly. What if they're not? Well, the first law of any civilization is survival. So I just got through reading a book which explores that in pretty good detail. If you're an avid reader, especially if you like to read science fiction, be sure to read a book called, I think it's called The Three-Body Problem. And it's all about the possibility of discovering life that may not be so friendly. Any other questions about anything?
One question.
Yep.
When I look outside at night, there seems to be a bright star or
In the west?
I'm not sure if it's in the west,
Yeah.
but wherever I live, I see it.
Yeah, that's Venus.
What, is that a planet or
Yeah, that's a planet, Venus.
Venus?
Venus. And in fact, if you go out and look tomorrow, you'll see the moon's practically on top of Venus. That's one of the interesting things about the moon. The moon moves pretty fast in the sky. So if you look at it from night to night, you can see it's in vastly different places. And a lot of times it comes close to other objects and always makes an interesting sight. In fact, just like 2 months ago, you could see Jupiter and Saturn and Venus and the moon all close to each other. It was beautiful. So if you have the opportunity to go outside, like right now when it's just now getting dark, it's a great time to go out and look. Yeah, you have a question?
Space station.
Yep.
Do you have any comments about it? Or we did see it pass over in Ashland.
Can't hear you.
Oh, the space station. Do you have any comments?
Space station? Oh, the space station. Yeah, you can see it on a regular basis. If you go to a website called heavens-above.com, it'll tell you when the space station is going over. And it's really bright, so it's really easy to see. And it's easy to notice because it moves, right? Whereas most of the things you see in the sky aren't moving where you can see them move. The space station is 250 miles above the Earth, and it moves at 18,000 miles an hour. So it looks like it's just crawling across the sky, but it's moving pretty fast. In fact, it moves so fast, it orbits the Earth in 90 minutes. In fact, I have seen it twice in one night. You see it go across, and then 90 minutes later, it's gonna go across again. Not in the same spot, because the Earth is rotating while it's moving. So you might see the space station over here on its first pass and way over here on its second pass. Now I've got some posters up here. That's why I have the table up here, and I've got all kinds of interesting things that you can browse if you're ready to look at some more science fiction. Okay, what movies are you going to recommend? Are you going to try to get on your list? Terminator. And then the Europa mission. Oh,
2001.
oh boy, 2001. That's my all-time favorite. In fact, I'm so old that I still remember the premiere. I used to live in Oklahoma, and I saw the premiere of 2001 in downtown Oklahoma City. And it's still my favorite science fiction movie.
What about Alien?
Alien, yeah, absolutely. And there was only one 2001, although there was a sequel called 2010. There's 5 or 6 Alien movies, and they're all really good. The Alien series are really more, well, they're about 50-50 horror and science fiction, whereas 2001 is purely science fiction.
How did the scientists that are studying the stars and the continents and all, how do they feel about there being aliens out there somewhere in space?
They are, obviously they think that alien civilizations would be friendly, they wouldn't be looking for them. Right? Now, if they read this book, they may reconsider the three-body problem. Yeah, there's a theorem called the Fermi paradox that says basically if there are so many possible planets in the universe, why haven't we found life? That's a paradox. You would think that if the more planets you have, the higher the possibility of life, right? But we haven't seen it. Of course, one possibility is that they're there, but they're so far away, we can't see them. I mean, our nearest star is 4 light years away. In other words, it takes light 4 years to get here. So that star could be completely gone, and we wouldn't know it for 4 years. Just like our sun. If the sun blew up, we wouldn't know it for 8 minutes, because that's how long it takes the light to get to us. So we'd be dead, but we wouldn't know it for 8 minutes.
But our planet would only be known to others in the last, 150 years since we developed
Yes.
telephone, telegraph, that sort of stuff.
Yep. Yeah, that's another factor. Civilizations could have come and gone, many years ago. So there's nobody left for us to discover. Maybe they were on a planet system where the sun blew up and took them with them. They're gone, and the civilization was there, but we'll never know it.
60 Minutes had an expose on the Webb telescope.
Oh, yeah, the Webb telescope.
Looks to the edge of the universe, the farthest star,
Yes, the Webb telescope,
18 billion light years away.
yeah.
1 billion light years is a long way.
Oh, yeah,
18
yeah.
billion light years, and so that's out there, been sending out signals, and we could have missed it.
Absolutely. Yeah, the Webb telescope is the largest telescope we've built in space. Bigger the telescope, the further back we can see in time, because the further away we can see things. So the Webb telescope is opening up a whole lot of new avenues to explore. The bad news is all that stuff is so far away, it's almost meaningless to us. I mean, we haven't even explored the entire solar system yet, right? We're just now sending rockets to the moons of Saturn.
Last night on 60 Minutes, they talked about the Webb satellite.
The what satellite? Oh,
Well, they said satellite, but I don't know. Telescope?
oh, the Webb telescope. Maybe.
They called it, I think, a satellite because it's infrared.
Maybe they were.
Launched by satellite, but it gets spread out as a telescope, and it reads infrared
Space, it
only.
gives you color. And it was so fascinating.
I think that's,
Pictures,
yeah.
all about that.
Yeah, there's a lot of different telescopes in the sky. Some of them concentrate on the infrared portion of the spectrum. Some concentrate on the ultraviolet part of the spectrum. There's many kinds of light that we can't see, but telescopes can see. And then they can convert it to an actual image that we can see. Yes, question?
I have a stupid theory.
That's okay.
Maybe these black holes are collapsed planets.
They could be, because when things get sucked into a black hole, it could have been a planet, it could have been another star. Yeah, it could be a lot of the different things. And then, yeah, I don't think, well, I mean, your guess is as good as mine if you could actually have life inside a black hole, but I don't think so.
Oh, no, I don't think they're still living. I think they're in heaven.
Oh, yeah. Like, maybe they once were, but not anymore. They're all smashed like that. Yeah, that would not be a pleasant thing. Anything else?
Thank you very much.
Okay. Yeah, you're welcome. You were a good audience. I really enjoyed it. They had some really good questions.
Yes,
Okay.
thank you again for coming. And like Mr. Brucker said, he has stuff up here if you want to look. Otherwise, I hope everyone has a good night.